All right, gentlemen, welcome in. Let me see. I think we got one more. Yeah, it's no major announcements. There's no major announcements. It's just a usual. What I'm going to be doing today is just kind of continue to kind of work on some questions. So we made our way through all the assigned homework questions, but on exam two, I basically pull questions from the homework, but there's going to be like a bunch of questions that I don't ask in the homework that could pop up, right? So I'm going to go back and try to see can we find some of those questions that were not necessarily assigned, but you might see on the exam, right? So I'm going to go back and see can we find some of those questions. And I mean, a lot of them are similar. It just might be, every now and then you do find something that's like, okay, wait a minute, let's talk about this, right? So with my 9 o'clock, with my 9 a.m. class, we finished out section 1.6, and I don't really want to start chapter two until we finish exam two, right? So this is the end of week 6, so we still have all of next week, and then after that is going to be exam two. I might just I still haven't made the scheduling wizard. I'm still kind of working out those details like in my mind. But I'll set it up and we'll connect. And again, the oral component for so basically for exam two, you can expect a similar setup. It'll be just like exam one. I'm just gonna make an oral component where each student like schedules a time slot that works for them, and then you just kind of defend yourself against some questions for like 10 or 15 minutes. And I mean, I'm not trying to, and it's only going to be like 20% of that exam, 20% of that exam. So I don't want it to be weight. I don't want it to have too heavy a weight. I just want to see where you all are, just get a feel for where you are. That's all. That's the intent of that. All right. I'm not trying to like no scare tactics or nothing. I'm trying to keep it light. I just want to get a sense for where you guys are. Right. Um, and then exam two is going to be focused on sections 1.4, 1.5, and 1.6. Let's see, this guy. Okay, got him, coach. All right, so let's just kind of continue working our homework questions. And again, the ones that I'm working, this name is so interesting because it looks like Robin Williams to me, but that's not his name. But I always want to say Robin Williams. Um, Yeah, so I'm just going back to section 1.4 and trying to see can we find some of those questions that we may not have talked about, but we don't have to do any of these in particular. So if you have one that you'd like to see, just bring it to my attention and we can talk about it. Okay, that's looking good. Okay, so yeah, let's just go ahead and do this one real quick. Actually, I was going to take some notes. We've done this one. Notice that the y-intercept is 4, and then we have this x-intercept of -4. Usually those have a slope of 1, and we know that the b is 4. So I'm just going to, this one should be x plus 4. If I need to show those details, just let me know and I can go back and show them. So again, y-intercept of 4, x-intercept of -4. Notice this has a positive slope. It can't be c or d because those both have negative slopes. As we trace it left to right, they go down. And I think b has the wrong y-intercept. So the only one that's correct is a, or even close is a. Okay. All right, on to the next one. Let's see. Let's take some notes on this one. This one's a little bit more involved. So let me see. Paper. And like we should get some more interesting questions than I know we have a good amount to go through. Um, Hopefully we can get some interesting questions. So I keep having students coming in. So when you guys come in, it kind of anyway. I'm gonna mute my audio so I can focus. So we're asked to write a linear function. Let me see. So this is fine. So this comes from section 1.4, question number 3. I'm going to say write a linear function. I'm just taking some notes. Okay. Okay, I'll check the chat momentarily. Write a linear function. So we're given f of -1 equals 1 and f of 3 equals 9. Okay. This is this guy. Okay. So let's hop over to the tablet and see the notes that I took. Uh-oh, are you showing? Are you not displaying? Let's see if I reboot this, if that fixes that. Let's see, and if that doesn't fix it, put this. Hmm. Give me a moment. I'm just trying to get this to show back up or display properly. It's looking good on my end. I don't understand why it's not showing here. Okay, let me reboot this real quick. Okay, that looks better. And then, okay. On the other side, this is just, I'm just trying to get it into display mode. There we go. Okay. Yeah, it's a little bit trippy, but it's okay. Okay, I think we're back. Okay. Oh, you guys can't see it. Resume the share. Let's do a new share. And we want to add this share. Okay. All right, I think we're good to go now. Okay. So we want to find a linear function that passes through these 2 points. Okay. Hopefully you've had a little bit of time to try it yourself. So with something like this, the first thing I would do is write the set of ordered pairs, right? So for instance, the first one is when x is -1, the corresponding y is 1. When x is 3, y is 9, right? So we have these 2 points that we're trying to find the line through, right? The next thing I would recommend is label them. x1, y1, x2, y2. Also, anything that you see me writing, you can. I load a copy of the PDF of all the stuff that I write into our Blackboard page, right? So anything that's associated with our interactions is you can find it on Blackboard. So we have the 2 points. Let's go ahead and find the slope. Slope is going to be what? The rise over run, which is change in y over change in x. Not that one. There it is. Okay. So let's see, slope. So that's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the slope, right? And again, this is a slope formula, slope between 2 points. Okay, so let's plug in what we have. y2 is 9, y1 is 1, x2 is 3, minus a -1, right? So that's going to be 8 divided by double negative becomes positive. So 3 minus -1 is the same as 3 plus 1. So 8 divided by 4 is 2. So that's our slope. All right. So then we have our slope. I did a demo on point slope earlier. I'll go ahead and do it for you all as well. So the point slope formula, you use this when you're given when you have a point and a slope, right? The point slope formula. I usually just go straight to slope intercept form, but this is fine too. So point slope goes y minus y1 equals m times x minus x1. It's just an alternative, right? So let's plug in what we have. We're going to keep this first y because we want an equation. y1, we see at the top of the screen, we can put in 1. The slope we just found is 2. We're keeping the x because we want an equation. And then x1 is -1. Notice my use of parentheses. That negative, I put it in its own set of parentheses, right? So let's do this. So double negative becomes positive. Let's account for that change. Y minus y1, the 2 comes down. This becomes x plus 1, all right? Next, let's go ahead and distribute this 2, okay? The y minus 1 comes down. Now, on the right-hand side, we get 2x plus 2. And then let's solve for y. We're going to say plus 1 on both sides, on the left and right side of the equal sign. 1, positive 1 plus negative 1, they add to 0, so they cancel. We're left with y equals, and then 2 plus 1 is 3, so that's 2x plus 3. And then just to put it in function notation, we would say f of x equals 2x plus 3, right? Let me do like this. I'm going to shrink this down just because I wanted to fit like here. Okay. So we got a result of 2x plus 3. Okay, so we're going to hop back over to Pearson and check that result. Come on. Okay. Let's see. Okay. So that one, you know, I felt like it wasn't as straightforward as the other one. We got this 2x plus 3. And let's check it before we submit it. For instance, when x is negative 1, the output should be 1. So then 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. When x is 3, the output should be 9. So 3 times 2 is 6. 6 plus 3 is 9. So they both work. I'm going to just go ahead and hit enter and go on to the next one. Let me check the chat real quick. Is it evening? It's not the evening. It's more like afternoon, but greetings. Okay. So let's see. Okay, so we got a y-intercept of 3 and a positive slope of 2. So it can't be A, right? Because A has a negative slope. It also can't be C, because that has a negative slope. It can't be B because the y-intercept is negative 3, but our y-intercept is positive 3. So by process of elimination, the only one that's left is D. All right, let's go to the next one. Let's see what else we can find. Sketch the graph. Let's do it since we're here. Let's see the time. Okay. So this question comes from 145, so 1.4, question number 5. See, it says to find a linear function. I'm just taking notes. So we have f of negative 1 equals 2. So this is the repeat, f of 3. Let's see if we can find something different happens. Sometimes they look similar and they're not. Let's hop like this. Okay. Okay, so if we repeat what we did, when x is negative 1, y is 2. When x is 3, y is 10. All right, we're going to label it x1, y1, x2, y2. Right? Slope formula is y2 minus y1 over x2 minus x1. Again, this is our slope. If we plug in the corresponding components, y2 is 10, y1 is 2, x2 is 3, x1 is negative 1. Right? On top we get 8, on bottom we get 4. It just happened to be 2 again. Okay. Hopefully this is okay. Okay, so instead of using point slope, I'm going to just go ahead and start. This is the slope formula. I'm just going to start with the slope-intercept. Slope-intercept formula. Right? That's basically the y equals mx plus b, right? If we're doing y equals mx plus b, we found the slope, but we don't know the y-intercept, so we're just going to choose a point. I'm going to choose the second point because the first one has the negative, and I'm just trying to keep it simple. So if we let y be 10, we just found the slope to be 2, we let x be 3, only thing we don't know is the y-intercept. So then ultimately, if we solve for b, what we're going to do is subtract 6 on both sides. All right, I'm subtracting 6 on both sides. So a number plus its opposite adds 0. 10 minus 6 is 4. Right? So we just found the y-intercept. So then ultimately we get y equals 2x plus 4. Right? And then we can rewrite it as f of x equals 2x plus 4. Okay, we're going to check it and submit it, provided it works out. Okay, so let's go back to Pearson. Okay, let me see. We got 2x plus 4. Notice when x is -1, the answer is 2. When x is 3, 3 times 2 is 6 plus 4 is 10. So they both check out. Okay, let's go on to the next one. I think the chat is okay. I haven't seen any movement. The y-intercept is 4, so it can't be b. And it can't be C and D because they have negative slopes. We have a positive slope, so the only one is A. Okay, let's see what else we got. Linear function that has these values, sketch the graph. Sure, let's do it. So this comes from section 1.4, question number 7. 1.4, question 7. I'm going to say find the linear function. We have f of -4 equals 3 and f of 2 equals 6. Okay, let's hop over here. -4 equals 3, 2 equals 6. Okay. So then the ordered pairs, we have what? -4 and 3, and we have 2 and 6. If we label them, x1, y1, x2, y2, right? I don't know if you notice that the speed is going faster because that's how it goes. Like when you want to get to a point where you're not even really thinking about it. I mean, you do want to think about it, like if you don't just automatically know, but you want to do your best to get to the level where you can do most of them without really thinking. But it's okay. So then slope formula, right? y2 minus y1 over x2 minus x1. And I'm not talking about like a critical thinking question, like something that you've never seen before that you have to figure out. That's different. But I'm just saying a lot of these should be like, you shouldn't even have to think. 6 minus 3 over 2 minus -4, right? On top we get 3, on bottom 4 plus 2 is 6, so that's a half. Okay, stop me if anything is not clear, if I need to go back and kind of change the rhythm or pace. Okay, so we have our slope. I'm just going to use my slope intercept, so I'm just going to use my y equals mx plus b. Also, I don't know if you notice, like every time I use a formula, I write it down. That constant writing the formula, that's how I remember it, because you do it over and over and over, so that's how you learn it. Let's see. So we found our slope. Let's use the second point because there are no negatives. So our y is 6. The slope is 1/2. X is 2. Only thing we don't know is b. Half of 2 is 1, right? So then to solve for b, you subtract 1 on both sides, right? A number plus its opposite adds to 0. Ultimately, we get what? B equals 5, right? So then we're going to get y equals the slope, which is 1/2 x plus 5. That's not a 5. And we can write it as f of x equals 1/2 x plus 5. Okay. So hopefully this is okay for you guys. All right. So let's hop back to Pearson, and we're gonna check it before we submit it because this is something that we can check. So we got 1/2 x plus 5. When x is -4, half of -4 is -2. -2 plus 5 is 3. So the first one checks out. When x is 2, half of 2 is 1. 1 plus 5 is 6. So they both work. I'm going to submit it and go on. Okay. So then the graph, the y-intercept should be 5. It can't be b. That has the wrong y-intercept. And it can't be c and d because they both have negative slopes. So then based on those pieces of information, it would have to be a, provided the correct answer is shown. Let me see. The y-intercept is 7. The x-intercept is -7. So this one should be x plus 7. thing. Let's check it before we submit it. When x is 0, y is 7. That checks out. When x is negative 7, y is 0. So I'm going to go with it. Okay. Y-intercept is 7. This has a positive slope. It can't be A and B because those both have negative slopes. C has the wrong y-intercept, so it would have to be D. Okay. Let me see. Find the intervals, okay, over which the graph is increasing, decreasing, or constant. So notice that the highest exponent is a 1. You should recognize this as a straight line, as a line. The y-intercept is -3. The slope is +3, right? So it should be a diagonal line with a positive slope. So it's going to be increasing. It's never decreasing. It should be increasing over its entire domain. The domain of a line is all reals. So that's negative infinity to positive infinity. Okay, hopefully that made sense. It wouldn't hurt to look at the graph, but I felt like you can visualize this one. Identify the intervals over which the function is constant. So a diagonal line is not going to be constant anywhere. Okay, increasing, decreasing, or constant. So with this one, I would recommend looking at the graph. If you have a graphing calculator, you can graph it and look at it, and you can see where it's increasing, decreasing, or constant. I want to say this is a power function. This kind of almost looks like an S. As you trace it left to right, it's going to be increasing. It almost looks like it flattens out, but it doesn't. Because there aren't any other terms or anything, it's an S, but it never decreases. It's always increasing. It's increasing over the entire domain, all reals, right? This is kind of like an S shape. So I'm just not. Oh, wait a minute. Let me see. What did I put? Increasing, negative infinity. Oh, sorry. It has a negative leading coefficient, so it's decreasing. So there's no interval where the function is increasing. Again, if you look at the graph, normally without that negative leading coefficient, it would be increasing from left to right. Because it has a negative leading coefficient, it's going to be decreasing across the entire domain. So that's going to be decreasing D, this one. Okay. And I kind of was using like transformations of function there a little bit. Identify the interval over which the function is constant. It doesn't ever go constant. This one. Okay. All right, so this is this is a discussion on even, odd, or neither, right? Let me just kind of refresh your memory on the definition of even, odd, or neither. I'm gonna hop over to the tablet and just write a quick definition. Okay. So a function, the definition of a function being even. So even means whenever we evaluate. So the first thing is when we look at f of negative x, we get back the original. All right. A function being odd by definition is when we look at f of negative x, we get negative of the original. Okay. Some other properties of even functions, they have y-axis symmetry. And also another thing is whenever we have x comma y, we also have negative x comma y. All right. So those are some properties of even functions. A few additional properties of odd functions. They have origin symmetry. And whenever we have x comma y, we also have negative x comma negative y. All right. So those are properties. So the official definition of even is the first line. Official definition of an odd function is the first line under odd. And then we have these additional properties of those concepts, right? So if we take these and apply them to this question in particular, so we can use the third line, right? Notice that the x's change, but the y's changed as well, right? So when we change both the x and the y, then that's an indication that the function is odd. See, this x, we have x comma y, and we also have negative x comma negative y. So then that's an indication that this function is odd. Okay. let me check the chat really quickly. Okay. Let me see something. Testing. Yeah, that looks good. I'm gonna go with it. Okay. Okay, so same thing here. If we apply the concept, let me see. Notice the x's changed, but the y's did not. So that's an indication that this function is even. X's changed, but the y's did not. Okay, so this one asks us to determine algebraically whether the given function is even, odd, or neither, right? So let's take a look at this. All right, so determine algebraically. Okay, so let's take some notes. So this question comes from section 1.4, question 25. 1.4, 25. I'm going to say, is it even, odd, or neither? And we have this g of x equals 8x squared minus 4, right? Also, just I don't know if I mentioned this to you all or not. My conversations are kind of running together in my mind, but anything that you see me right here, I make a PDF available. Like with all my classes, I put them all in the same location. I make a PDF copy of all the stuff that you see me writing available for you all. It's on our Blackboard page. So even, odd, or neither. So to do this algebraically, what we do is we replace each x with negative x, we simplify, and then we interpret the results that we get, right? So first thing I'm going to do is replace each x with a blank set of parentheses. So I'm just going to bring down my equal sign. We have this g of x. Again, I'm just replacing each x with a blank set of parentheses. The next step is what goes into the blank parentheses. We're going to put negative x. So into each blank parenthesis, we put negative x. Okay. Next, we simplify. So with this first term, we have an even number of negatives, all right? So if it's an even number of negatives, is the final result for that term, is it positive or negative? It should get positive, all right? The minus 4 comes down. Is this the original? Notice that this is indeed the original, right? So we have g of negative x equals g of x. So g of negative x equals the original. That's the definition of a function being even. All right, so this one should be even, which means that it should be symmetrical about the y-axis. Whenever we have x comma y, we also have negative x comma y, right? Let's hop back over to Pearson. So we said this one was even. If you think about it, this is a parabola that was stretched vertically, so it's by a factor of 8, so it's kind of tall and skinny, and then we move it down by 4. So remember, we said even has y-axis symmetry, so if we have a U-shaped graph that we only move down, you should be able to fold it along the y-axis, and the two halves will match up, right? Okay. Determine if the function is even, odd, or neither. Okay, let me write this one out for you guys. So this comes from section 1.4. This is question 27. All right. I'm going to say even, odd, or neither, question mark. And we have this f of x equals x to the power of 5 plus x cubed, right? Let me see, it's showing. I don't know why that's not working. Okay. So again, same thing, what we do. First, we're going to replace each x with negative x, and the first thing I'm going to do is replace each x with a blank set of parentheses. So I have my f of x, I got x to the power of 5 plus x to the power of 3. And into the blank parentheses, we're going to put negative x, and negative x, right? So now with this first term, if we have an odd number of negatives, the final result is going to be negative. Second term, we have an odd number of negatives being multiplied, final result is going to be negative. Notice that this is not the original. Notice that this is not the original, right? So let's factor, but we can factor out a negative from both of these terms. And what that's going to leave us with is x to the 5th plus x to the 3rd, right? Now, notice that this is negative of the original. This is negative f of x, right? So we have f of negative x equals negative f of x. That's the definition of a function being odd. So that's how we would do that algebraically. Okay, let me check the time. Okay. I don't know why that's not working anymore. So this one should be odd, which means it should be symmetrical about the origin. Whenever we have x comma y, we also have negative x comma negative y. Okay, this one, right? This one's similar to the one we just did. It should be odd, right? For the same reasons. I'm just gonna, let me think about it. Yeah, I'm just gonna put a odd as the same argument, all right? Same reason. It's like similar to the one we just did. Just this one, I think I'm gonna write it out because it's a little bit more involved. Okay. So this is this comes from section 1. This is comes from section 1.4, question 31. I'm gonna say even, odd, or neither. All right. And in the denominator we have 5x squared plus 8. In the numerator we have negative 2x. And this is our h of x. Okay. Yeah, let's talk about this one. Okay, so we can kind of repeat the steps that we did before. First thing what we're doing is we are replacing each x with negative x. So the first thing we're going to do is replace each x with a blank set of parentheses. So we have this h of x. Let's see, on bottom we have 5x squared plus 8. On top we have a negative 2x. Okay, and then into the blank parentheses we're going to put negative x, negative x, negative x, right? Okay. So then on top, double negative becomes positive, so that becomes a positive 2x. On bottom, if we look at this first term, we have an even number of negatives, right? So even number of negatives is going to be positive. So that's going to be 5x squared plus 8, right? Is this the original? This is not the original, but we can rewrite 2x as negative 2x, like a double negative, right? Okay, yeah, let's do this. I think this is okay. So again, we can rewrite this in the following way. This is going to be equal to basically the same thing. I'm just going to copy and paste. But if we factor out a negative out of the numerator, this is going to become negative, and we can basically say like this, right? So basically I rewrote that 2x as negative 2x, right? A positive is the same as a double negative. So then now notice that this is negative of the original, right? So this is equal to negative h of x, right? So this function should be odd. All right, that's why I wrote it out, because I was like, okay, these type, you kind of need to work it out and simplify it and see what happens. Because it's sometimes you don't know until you do it a lot of times, right? So let's go with odd and see what happens. Let me get the student real quick. Are they for the next class? I think they're in the next class. Let me see the time. They might be early. Yeah, I think they're in the next class. I'm not going to worry about it. I'm gonna, yeah, I'll let them in. Okay, so let's see how do we do it. So we got a result of odd. Okay, I think that's okay. All right. If you're just joining us, I think you're in the next class. I just went on to let you in. Just come back. You know, I mean, you're welcome to stay, but you know, Just be sure to, because I'm gonna like reboot everything in time for our next class. But we still got 10 minutes, at least 10 minutes here. But I'm under the impression that you're in the next class because when I checked the roster just now for this class, I didn't see you. Let's work this one out. Notice how this one looks similar to the previous. So this is why I was decided to go back because I realized that like because basically the way I've been doing you guys exams, like I'll pull from all the questions instead of just the questions I assigned you. So since we have time, I was like, well, let's see, can we find some of those questions that weren't necessarily assigned that could show up on the exam, right? That's the intent of these sessions. Now, this comes from section 1.4, question 33. 1.4, question 33. I'm going to say even, odd, or neither. Even, odd, or neither. Okay, question mark. And then the question is, the numerator, we have x squared minus 5x. The denominator, we have 2x to the power of 4 plus 3. And then we have this f of x. All right, okay, I was just taking some notes. I don't know how to get that to work. Okay. All right, let's do the same thing. So first step that we want to do is replace each x with a blank set of parentheses. So I'm just kind of repeating the steps that I did before, and then I'm replacing each x with a blank set of parentheses. All right. 2x to the power of 4 plus 3, right? And then into each blank parentheses, we're going to put negative x, right? Okay. So now we just take it term by term. Remember, terms are things that we add and subtract. Factors are things that we multiply and divide. So let's take it term by term. If we look at the first term, is that negative x squared, all right? So double negative, an even number of negative is positive. The second term, we have a negative 5 times a negative x is a positive 5x, okay? On bottom, that first term, we have an even number of negatives, so that's going to be a positive 2x to the 4, and then the plus 3 comes down. First question is this the original? This is no. If we factor out a negative from either the top or the bottom, can we get negative of the original? And that's no as well, all right? So because like if we factor out a negative on top, we're going to be left with a negative times the quantity, negative x squared minus 5x, right? We can't get back to negative of the original. So this is an example of something that's neither. This is neither even nor odd. Okay. All right, let me see. Neither even nor odd. Let me see the time. Let's try to hang out for like about 5 more minutes. The graph of the function is given to the right. Use the graph to find each of the following: the domain and range. Okay, so what's the domain? So given this image, all right, domain of a graph is the very left to the very right. Domain is concerned with, okay, what are the possible input values here, right? What are the possible values that x takes on? Another way to visualize this, if you take this image and smush it onto the x-axis, any point that is touching on the x-axis, that's your domain, right? So if you take this image and you flatten it and smush it onto the x-axis, you're going to notice that, oh, it'll touch the x's going from -1 up to x equals 9. All right, so domain, that's called a projection. If you take the image and flatten it onto the x-axis, that's one way, another way of visualizing domain. But originally I introduced this as the very left to the very right. All right, so it goes from -1 to 9, but we need the proper grouping symbol as well. Take a quick moment and decide for yourself, do you think this should be a parentheses or should this be a square bracket? All right. And so parentheses in this context, why are these guys like driving like, it's that same car. Like, why does he keep doing that? This is like a residential area and it's like a little side street. Anyway. So parentheses in this context means not only do we get really, really, really close to that number, but parentheses means we get really, really close to the number, but we don't include the number. Versus square bracket means we get really, really, really close to the number and we do include that number, right? So This graph does indeed touch -1, so we would use a square bracket, and it also touches 9, so we would use a square bracket there as well. So not only does it get close to those numbers, but it actually includes those numbers themselves. Right? You have to kind of use your imagination a little bit there. The range. So if domain is the very left to the very right, the range is the very bottom to the very top, right? So the lowest y value will be this -2, and the highest y value will be this 1. Similarly, if we were to take this image and smush it onto the y-axis, it's going to touch as y goes from -2 to 1. All right, so that's our range. That's projecting onto the y-axis. So we said the lowest y value is -2, the highest y value is 1, and we actually reach both of these numbers, so we're going to put these in square brackets. All right. Not only do we get close, but we actually include those numbers. Okay. The x-intercept. Let's see. I don't know that we can eyeball it. No, we can't eyeball it, right? So what we can do, we have these 2 points. We can find the equation of the line through those 2 points, and then we can calculate the x-intercept. So let's take some notes. This is going to be our last one. So this comes from section. Then I need to take a break. 1.4, question 35. We want to find the x-intercept, so I'm just going to label it as x-intercept. Put a question mark. Now we have these ordered pairs. It looks like it's -1, -2, and then we have this other ordered pair 3, 1. All right. Let's hop over to the tablet, and so basically we're trying to find the x-intercept of the line that passes through these 2 points, right? So we know what to do here. Let's label x1, y1, x2, y2, right? Let's see, we want the slope. So the slope formula is y2 minus y1 over x2 minus x1. Again, this is our slope. If we plug in the corresponding components, y2 is 1, y1 is -2. Notice my use of parentheses. x2 is 3, x1 is -1. Okay. So then 1 plus 2 is 3. 3 plus 1 is 4. So then this is our slope. All right. So next, let's go ahead and find our y-intercept. All right. So we're going to use the slope-intercept, which is y equals mx plus b. I'm going to choose the second point, so I'm not dealing with a whole bunch of negatives. So then my y is 1. The slope we just found was 3 by 4. X is 3. Only thing we don't know is b. All right. So then ultimately b is going to be equal to, now on the right-hand side, we got 9 over 4, so I'm going to subtract 9 over 4 from both sides. All right. A number plus its opposite adds to 0. So then we're left with, you can write it as b equals 1 minus 9 over 4. You can use your calculator here. I'm just going to use some arithmetic. So this is going to be the same as 4 over 4 minus 9 over 4, which gives us a -5 over 4. That's our y-intercept. All right. But I think the question asks for the x-intercept. So then ultimately, we get what? Y equals 3/4 x minus 5 over 4, right? And if we want the x-intercept, we set y to 0 and solve. I'm going to rearrange it. So I have this 3 over 4 x minus 5 over 4. Again, we set it equal to 0. We can add 5 over 4 to both sides. I'm just using inverse operations. Because of this negative here, that's why I added the 5 over 4 on both sides. A number plus its opposite adds 0. So then on the left, we still have this 3/4 x. On the right, we have 5 over 4. Okay, we're almost there, and I'm going to get you guys out of here. So now we wanted to do the inverse operation. If we have 3/4 times x, the inverse operation of multiplication is division. So dividing by 3/4 is the same as multiplying by the reciprocal. Multiplying by the reciprocal. Right? A number times its inverse, that multiplies to 1. So they essentially cancel. On the left, we have x. On the right, these 4's can cancel, and we're left with 5/3. right? So this is the x-intercept. Wait, let's go back and see what did the question ask for. All right, we found the x-intercept and we found the y-intercept. Let's see what did the question ask for. Oh, I didn't realize I didn't switch there. Okay, well, my YouTube family didn't see those notes, but that's okay. We want the x-intercept. So the x-intercept we got was 5/3. Wait a minute, something's off. Because it looks, oh, x-intercept, right? Yeah, I think we're okay. Yeah, 5/3. Okay. And then the y-intercept, we found it to be a negative 5/4. Was that it? Let me see. No, there's more. Increasing, okay, so increasing, right? So as we trace it left to right, it's going to be, it's initially it's increasing as x goes from -1 to 3. So we say it's increasing as x goes from -1 to 3. I think for our discussion, increasing, decreasing, and constant, we should always use parentheses. All right? Using parentheses forces us to always have at least 2 points. If we use square brackets, it's kind of hard to talk about the end point because you always need a second point. All right? So I'm under the impression that for increasing, decreasing, and constant, for our purpose, we should always use parentheses. Some books use brackets when talking about that concept, but the way this one is designed, it should be parentheses. Decreasing is never decreasing anywhere. I'm about to wrap this one up. Let's see the time. And then let me go ahead, paper. Constant as x goes from 3 to 9. And we're going to, again, it's square brackets from the same argument as before, 3 to 9. Let's see, what do we do? Constant is flat as x goes from 3 to, oh, sorry. I did and said the wrong thing after I just made the whole thing say, hey, we should always use parentheses for increasing, decreasing, and constant, all right? But again, it was wrong, right? Like, you know, the grouping symbols are important. There's no symmetry. Odd would be origin symmetry, which we don't have, and even is y-axis symmetry, so this one would be neither. Okay. Part of that was I was rushing. Okay, so that brings us to the time for this. Let me go ahead and, well, I'll make that available in just a moment. I'm going to go here and hop back to the tablet. So as soon as I stop the stream, I'll go ahead and make a PDF of all the stuff that you saw me writing. I'll make it available. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.